Okay, so when we have to sketch the graph of a function, and when it is in standard form, you would find the vertex first. And once you find the vertex, then you pick two x values to the right and to the left. So to find the vertex, we take the opposite of b. So here's our a, our b, our c, and multiply that by 2 times a. So the opposite of 16 is negative 16 divided by 2 times, well, negative 16 divided 4 is negative 4. And so where x is equal to negative 4, that's where our axis of symmetry will be. So we're going to sketch. Then remember, the axis of symmetry, that is really important because the axis of symmetry tells us that on both sides of that line, we're going to have our graph will be at the same height. Okay, so now we're going to take two values to the right and two values to the left. We're going to take negative 4, we're going to plug it into that equation right there. So y is equal to 2 times negative 4 squared. Negative 4 squared is 16. Positive 16 times 2 is 32. Plus 16 times negative 4, that's negative 64. Well, those two add to be negative 32. And then we're going to plus 34. So negative 32 plus 34 is positive 2. So negative 4, positive 2, that's our vertex right there. Now, I'm going to pause this for a second because I'm going to show you, instead of having to go back through and punch that into the calculator each time, I'm going to come over here and talk to you a little bit about the parent graph. Y is equal to x squared. So notice, when x is 0, y will be 0. When x is 1, y will be 1. When x is 2, y will be 4. And same with, if you put negative 1 and you square it, you'll be at 1. And when you put in negative 2, you'll be at a positive 4. So at 1 we're there, and at 2 we're up here, and it's going to be the same on both sides. So I'm going to put those values in. The reason I'm doing this is I'm going to show you a pattern that you can use for the rest of quadratics. Okay, so notice these heights. These are the heights over here. From 0 to 1, we went up a value of 1. And then from 1 to 4, we went up 3 more. So every time you have a quadratic and the lead coefficient is 1, that's going to be the pattern from the vertex as long as you're only moving over on the x-axis by 1s. If in the table you put 0, then you put 3, then you put 6, that specific pattern is out the window. Now, if we had y is equal to 2x squared, well then that would increase 2, and then 2 times 3, that next pattern would be 6. If it was negative 2x squared, so the graph would look like this, that would be negative 6. We would go down, negative 2, and then negative 6. So I show you that for a reason, because you can look at this, and once you know the vertex, so this tells us that original, you can kind of treat it like slope, not really, but it tells us how far you go down and over to get to the next point, or how, in this case, up, because that's positive. So we're going to go up 2 over 1, up 2, back 1, and so at negative 3 and negative 5, we're at a height of 4. And look at that. So that next pattern, since this pattern is 2, that next pattern should be 6. So this should be 10, and this should be 10. But let's check it out. Let's put negative 2 in here. So if we put negative 2 in there, Negative 2 squared is 4. 4 times 2 is 8. 16 times negative 2 is negative 32. So when you add those two together, you get negative 24 plus 34. Look at that. So without even doing the table, plugging it in, when you can use a pattern like this, so even without the table, if you know we went up 2, then for the next one, we're going to go up 6. So we're going to go over 1 and then go up 6 more. 1, 2, 3, 4, 5. Ah, there we go. So if you pay attention to patterns, it makes graphing this very, very easy. And then later when you do domain and range, sometimes even then, patterns help. Now, this is crazy. This time it's a negative 3. So if I erase this and I'm now multiplying, well, negative 1 times 3 is negative. So we're going to go down 3 over 1, down 3 back 1. And then negative 3 times 3 is negative 9. And then from this point and this point, we're going to go down 9 over 1. So that quadratic is going to look something like that. All right, so without even using a table of values this time, the only thing we have to do is find the vertex. So x is equal to the opposite of the b value divided by 2 times the a value. So negative 6 is our b. The opposite of negative 6 is positive 6. And then this is our a, 2 times negative 3. Well, 6 divided negative 6 is negative 1. And then we're going to put negative 1 into the equation. So negative 1 squared is 1. 1 times negative 3 is negative 3. Negative 6 times negative 1 is 6. Add those two together, you get 3. 3 subtract 7 is negative 4. So, and where x is equal to negative 1, that will be the axis of symmetry. So this is skip counting by 2, so we're going to have to do the negative 1. So at negative 1, 4, that's the vertex. We're going to be going down. Now look it, we're going to go down 3. Well, negative 4 subtract 3 is negative 7. And look it, when x is 0, we should be down there at negative 7. Since we went down 3 times, the normal pattern is the next pattern is 3, but 3 times negative 3, we're going to go down negative 9. So negative 9 and negative 7 is negative 16. And so we're going to go down 3 over 1, and then down 9 over 1. Okay, that is when it is in standard form. Vertex form, you're completely ready to graph without a table. Just use the information. So you can go ahead and say vertex. So look at, this is vertex form. So you take the opposite. So x is equal to positive 2. So where x is equal to 2, that will be the axis of sim. So go ahead and sketch in the axis of sim. All right, now we also have the y value. So you just take this exactly. So that's the y value of the vertex. So that's, negative 3. So at 2, negative 3, and then look at, this tells us we're going to go down 2. So normally we go either up or down 1 and then up or down. 3. But since there's a 2, we're going to go up or down 2, and 2 times 3 will go up or down 6, in this case down. So from right there, we're going to go down 2, and then we're going to go down 6. So we're going to, from right here, we're going to go down 2 over 1, and then down 6. So 1, 2, 3, 4, 5, 6 over 1. And then remember, these are a mirror image. They're called reflective points, reflection points. And I don't need to have those not drawn there like that. Now, if you're a little bit nervous that you might do that wrong, then double check. If you put 4 in there, 4 subtract 2 is 2, 2 squared is 4, 4 times 2 is -8, -8 subtract 3 is -11. Oh, look it, we are at -11. So, using the pattern method, and there was no table. So, this method, notice this says -3 right there. When it's in vertex form, that's not where it crosses the y-axis. So do not mistake that. And then look at this graph will not cross the x-axis. So this quadratic has 2 imaginary roots. Okay, graphing in vertex form using a pattern, and using patterns when you're graphing just standard quadratics.